Okay, let's take a look at cryptography, encryption, ciphers, and in particular, Caesar ciphers. Cryptography is just a science of hiding information. Encryption is hiding information by obscuring its meaning, as opposed to steganography, which we'll talk about later in this module. And a cipher is just the algorithm or steps used to obscure the meaning of something. So let's take a look at a simple Caesar cipher. Caesar cipher is named after Julius Caesar, who in the old Roman days, when he wanted to hide a message, he would use this Caesar cipher in case one of his couriers were intercepted. The enemy wouldn't be able to understand what the message meant. So for us, we're going to use this for a baseline. We've got the letters A to Z, we've got a space, and then the numerals from 0 to 9. So let's say the cipher is to just move the code for a letter 2 places to the right of where the original letter was. So, for instance, A becomes a C, B becomes a D, C becomes an E. So what would the code be for Trent U? Well, T becomes a V, R becomes a T, E a G, and a P, the space becomes a 1, and U becomes a W. So the code for Trent U would be VTGPV 1W. So to decipher the code, we just reverse the direction. So we take the coded letter and then shift it two places to the left to recover the original message. So Caesar ciphers, they're fine in the pre-computer days, but with a computer it's very easy to crack a Caesar cipher. There's not a lot of possibilities to actually check. Plus the fact that some letters are much more popular than others. If you look at this URL and go to Wikipedia and check out letter frequency, you can see which are the most popular letters in many different languages. And they've even analyzed the most popular letters used in different types of publications. So scientific publications, social media would have different popularity for different letters. So in English, the 6 most popular letters are E, T, A, 0, L, and N for just general publications. So let's look at more complex Caesar ciphers, one that are hard to decipher even on a computer. So we can do this by just changing the direction of movement when we're trying to encode the letters. So we can use a key to state how many shifts, in which direction, and the number of characters that this applies to. For example, we could send a coded message like 6573 for the key. This could mean to shift the first 6 characters right by 5 places, and the next 7 left by 3 places, and then the next 6 right by 5, the next 7 left by 3. This is going to be very hard to decipher if you don't know what the key is. We could be even trickier if we hide the key. So we can choose a phrase, something like Trudy Jones. Trudy Jones has 10 different characters in it. So we can map each letter to a number. So take the first letter is a T, we can make that a 0. The R becomes a 1, the U becomes a 2, the D becomes a 3, the Y becomes a 4, the J becomes a 5, and so on. So for instance, 65 would become O, J, and 73 would be ND. So let's say that we are using Trudy Jones for a code phrase we want to encode Trent U again. Use the same template, the A to Z space and the numeral 0 to 9. So we're going to shift, say, the first 3 letters to the right by 2 and the next 2 letters to the left by 3. So in this case, our key would be 3223, or using the code phrase DUUD. So again, this is our baseline. So we shift the first 3 letters to the right by 2. So T becomes V, R becomes T, E becomes G. Then we shift the next 2 by 3 to the left. So N becomes K, T becomes Q. The next 3 to the right, so space becomes a 1, and the last letter U becomes a W. So the code for Trent U would become VTGKQ1W. This is going to be a lot harder to decipher than just a simple Caesar cipher. So to decode it, we would do the opposite. Take the first 3, go left by 2, the next 2 go right by 3, and so on. So it is important using a Caesar cipher that when you're going to decode it, you have to move in the opposite direction that you went to encode it.